We are the Gujarat Technological University. Since its inception over a decade ago, GTU has been empowering young and curating minds to realize their true potential. Over 4 lakh inspired students are enrolled with one of the premier academic universities in India. With more than 450 affiliated colleges in its fold operating across 5 zones of the state, GTU, the International Innovative University, your place to move forward.
Gives you a best wishes. Okay. Good morning, everybody. Looking to the spreading of coronavirus, it's better to remain at home. And here to promote the learning from your home, some videos are defined related to the subject digital communication. And this is the first video that I would like to share with you. So this is basically start from where we have stopped, and it's about digital career system. You can see this diagram. This diagram is already discussed earlier, so you are very well familiar about this diagram. And if you can see this diagram, so you can identify this is a digital communication system transmitter. Here, the first component is a source which generates the signal in form of analog. After passing through the sampling, this continuous time signal is converted in form of a digital. So, but this is a half done only. Using the sampling, the continuous time signal is converted to the discrete time signal. This discrete time signal is further quantized to get the binary data like 10110. So the analog signal here is finally converted to digital here by passing through the sampling and quantization. At the sampling, we will mainly concern about the Nyquist criteria should be satisfied here, and that state your sampling frequency should be at least 2 times of your original signal frequency. Then the quantization has various way to do the quantization. Maybe you can go with a pulse code modulation, differential pulse code modulation, data modulation, or maybe adaptive data modulation. That is already covered in the class. Then this binary data is to pass through the line code to get the shape of a pulse. And here also various line codes are available to encode the signal, on-off signal, polar signal, bipolar signal, or maybe a Manchester code. And all the line codes have different characteristic. The user are free to go with any one of the line code which satisfy their need. Then the output of line code is going to the pulse shaping circuit. The pulse shaping circuit is basically used to remove the inter-symbol interference. So whenever the signal is transmitted from the transmitter, there is no ISI. It's a ISI free signal. But due to the effect of a channel, the signal spread in a time domain and it combined with the neighboring pulse. And this effect is known as a inter-symbol interference. So pulse shaping is a method to shape the pulse in a form so inter-symbol interference can be minimized as low as possible. Now then, there are many more circuits are there. We are not going to discuss this at this point. But then it goes to the source encoding. Source encoding is used to compress the signal. Huffman code is used at this point. Then the output of source encoding go to the channel encoder. In the channel encoder, we have various options like as a linear block code. We can use the cyclic code, or we can have an option of convolution code. The channel coding is basically used to increase the reliability of signal or to detect or correct the error which is generated during the transmission the signal. So the extra bits are added with your information, and these extra bits are used to identify the error in the bit stream which is received at the receiver side. Now, output of the channel encoder is going to the modulator, and here it is also known as a digital carrier modulation. There are various way of modulations are possible, like as amplitude shifting key, frequency shifting key, quadrature phase shifting key, or quadrature amplitude modulations. We'll look at this all one by one. And then final signal is prepared at the output of digital carrier system is to be transmitted by the transmitting antenna. Now one may ask a question here, if the signal is basically in a form of digital waveform, so what is the need to convert them from digital to analog before the transmission by this block, modulation block? So on the subsequent slide, we will see the answer of this. What is the need of modulation at this point? Why the signal is basically captured analog in a form and then converted into the digital, and then all the processing is to be done here in the form of a digital signal. And at the end, before the transmission of signal, what is the need to convert them in analog form? So we will see here what is the necessity of the modulation at this point. So as we can see here, the importance of modulator. So the basic block of modulator, you are very well aware about this because we have already learned this thing in analog communication. So let's revisit the thing here, and I would like to refresh your memory. So modulator is basically a block which consists of two input. One input is baseband signal. So in earlier case, analog communication, the baseband signal is analog in nature, but it's a digital communication. So baseband signal is in form of a binary pulse. So it can be represented as a 10110 or may have a different combination. So baseband signal is binary in form. It is modulated by the carrier signal, and then finally here we are getting the output in form of a y of t. So b of t is the input, c of t is the another input, and then y of t is the output. Now here, receiver antenna size is directly proportional with the wavelength of signal, lambda. And if we want to deal with compact antenna size, smaller antenna size, then it requires to have a small value of lambda. Lambda is basically depends on the frequency. It's inversely proportional of the frequency. This equation states this, lambda is c by f. So if the goal is to make the lambda down, then the frequency of incoming signal should be kept high. So higher frequency, if this receiver is receive the signal of higher frequency, then finally it makes the lambda down. If f is large, lambda is down, and if lambda is down, then one can deal with a smaller antenna size at the receiver. Now we will see the scenario at this point. What is going on in the digital communication? We have a baseband signal, and baseband signal is fed up as an input of a modulator, and the output of modulator is y of t that we are transmitting. So baseband signal is basically the signal of a lower frequency. If we directly transmit the signal, or we can skip the modulator. So this lower frequency signal has higher value of lambda, and that it demands a large antenna size, right? And that we cannot operate the receiver size, because if lambda is in a few kilo, you can consider if the frequency in a few kilohertz, then it makes the lambda too much large. If you put the c is equal to 3 into 10 raised to 8 here, so it makes the lambda large in a few kilometer, and then the antenna size is also increase significantly, and that such kind of antenna is impractical to design, and we cannot deal with this, or we cannot sustain such kind of a communication system. So the thing here is, we do the modulation, and this process of a modulation in which we shift the lower frequency binary signal to some high frequency output signal y of t. So modulator is fed up with the two input, the binary of lower frequency, and the another input is a carrier signal with high frequency. And because of this high frequency carrier signal, it shifts the lower frequency baseband signal to some higher frequency output signal y of t. So whatever the signal we are transmitting here, y of t is of high frequency. Then for high frequency, the lambda goes down, and then we can deal with a smaller antenna size. So this is the main reason to do the modulation at this point. And this is limited for wireless communication system only. If you are dealing with a wireline communication system, so in a wireline communication system, the data is transmitted by the wire, and we don't require any antenna. The medium between transmitter and receiver is wire, and then we can skip this portion of a modulator, and whatever the baseband signal we can directly transmit. But for wireless communication, the channel is wireless, the transmitter is transmitting by the transmitting antenna, and receiver is receiving the signal with the receive antenna. So the modulator is required to shift the lower frequency baseband signal to higher frequency signal, and finally it is possible to capture your receive antenna of smaller size. So let's summarize the thing here. So modulation is a process to shift the lower frequency baseband signal to the higher frequency signal using the high frequency carrier signal, and the main objective to do this is to work with a smaller or compact receiver antenna size. Okay. So now in the next lecture, we will discuss about the various method of a modulation, like amplitude shifting key. Then we can discuss about the frequency shifting key. We will in amplitude shifting key, we will discuss about the MRE ASK signal. In frequency shifting key also we'll discuss about the MRE FSK signal. Then we will discuss about the phase shifting key, and in phase shifting key we basically discuss about the QPSK, BPSK, and if we combine the amplitude shifting key and phase shifting key in some way. So we have a quadrature amplitude modulation. We will discuss about the quadrature amplitude modulation in the next lecture. We will even discuss about the transmitter and receiver, the constellation diagram, the beat error probability about all this modulation scheme. And at the same time, the receiver side, we will even discuss about the various demodulators to decode the signals and get it in original form. We will even see about the very important modulation scheme known as a Gaussian minimum shifting key, GMSK, which is widely used in the GSM, Global System for Mobile Communications, which is a third generation system of a mobile communication. So we'll take a look about all these things. So it's a good day. We will conclude this lecture here, and good day to all of you. And be remain again. I repeat, be remain at home and isolate yourself from the social and be safe. Thank you.